All right, let's find the missing angle. Let's label our sides. We've got the hypotenuse, which is the longest side, the adjacent, which is in between the two angles, and the opposite, which is opposite the angle. We've been given the adjacent and the opposite. So which function has A and O? That's the tan function. So tan is the TOA, basically, TOA acronym, so it's O over A. That's how we remember how to do the fraction. And so let's substitute those values in. We've got tan theta equals the opposite over the adjacent, which in this case is 4 over 10. We need to rearrange this to find the theta, which is the angle. So we have to use the inverse tan function and times that by the ratio or the fraction, which is 4 over 10. So when we plug that into our calculators, here's what we get. We get 21.80 degrees. Remember the units over here, okay? And so that is question 1. Whenever we're finding the angle of something, always remember to use the inverse function, okay? So the next problem that we'll deal with, problem number B, letter B. So label the triangle. We've got the longest side, which is going to be the hypotenuse, the opposite, which is opposite the angle, and the adjacent, which is in between the two angles. We've been given the hypotenuse and the opposite. So which one has O and H? Which function has O and H? That's SO, the sine function. So sine theta equals O over H. Plug in the values. And now we need to rearrange to find that angle. So it's going to be inverse sine equals, that is actually meant to be times. I'll fix that in a second. So it's going to be inverse sine times, let me fix that up now actually. Inverse sine times 5 over 8. And when we plug that into our calculator, we will be getting 38.68 degrees. Don't forget the degrees. And that is our answer. Right. Let me just highlight that to make it look pretty. Before moving on to our next one, I'll highlight this one too. All right, moving on to problem C. So we've got the hypotenuse, adjacent, and opposite. And now we've been given the adjacent and the hypotenuse. So which function has A and H in it? Yep, it's a cosine function, ka, A over H. Substitute those values in. Got A over H, 2 over 10. And now we need to rearrange to find the angle. So I've got inverse cosine times 2 over 10. Let's plug that into our calculator and let's see what it chugs out. 2 over 10, bracket, and that equals 78.46 degrees. Beautiful. All right, moving on to the next one. So remember, we've got the hypotenuse, the longest side, adjacent, in between the angles, and the opposite the angle given. We've been given the opposite and the adjacent. Which of the functions has O and A? It's the tan function, equals O over A, TOA. So tan theta equals 6 over 3, substituting those values in. And now we need to rearrange to find the angle. So we've got inverse tan equals, times 6 over 3. So the angle for this is inverse tan times 6 over 3, and we get the value of 63.43 degrees. So that's the angle of this particular triangle. All right, moving on to the next one. We have to label the triangle. So we've got the hypotenuse, the longest side, opposite the angle, and adjacent. in between the two angles. We've been given the opposite and the hypotenuse, and so we'll use the sine function because that's the one that has O and H in it. So, okay, so we've got 3 over the hypotenuse, which is 5. Rearrange to find the angle. It's going to be inverse sine times 3 over 5. Beautiful. So we've got theta equals inverse sine 3 over 5. And that is 36.86. I'll round it up to 87. And that is the missing angle. I hope we're getting the gist of this. Pretty straightforward once you know what needs to be done, okay? So this triangle here, let's label it. We've got the hypotenuse, opposite, and adjacent. And now we've been given the hypotenuse and adjacent, A and H. Which function is A and H? It's the cosine function, ka, which has A and H in it. Now substitute the values in. Cosine theta equals 7 over 12. Rearrange to find the angle, which is inverse cosine times 7 over 12. Plug that into your handy dandy calculator. Also, you should make sure that your calculator is set to degrees, not radians, otherwise you will get some funky looking answers, okay? That's a pro tip. Alright, so we've got 54.31 degrees. Beautiful. So we've finished the first section of that worksheet. Alright, next triangle. What I want you to know here is these triangles can be a bit deceiving. So always remember that the hypotenuse is the longest side, which I've incorrectly labelled to begin with. So we've got the opposite, which is opposite to the angle, okay? Can't go wrong with that one. Then we've got the hypotenuse, which is the longest side, and the adjacent, which is in between the two angles, okay? So as long as you remember that, you can't go wrong with your labelling. All right, so what have we been given? We've got the adjacent and the hypotenuse, A and H. Which function is A and H? It's ka, the cosine function, A over H, ka. Let's substitute those values in. 12 over 13, we want to figure out the angle, so it's inverse cosine 12 over 13, and then we can plug this into our calculator. And that is 22.61, round up to 62 degrees. Cool. Again, pay attention to the next triangle. All right, so we have our, let me just border that off. Got our adjacent, which is going to be in between the two angles, okay? The adjacent, which is in between the two angles, the opposite, which is opposite the angle, and then the hypotenuse, the longest side, all right? So we've been given the adjacent and the opposite, O and A. Which function has O and A? That's our tan function. It's got O and A in it, it's toa. So tan theta equals O over A, toa. Substitute the values that we've been given, which is 4 and 13. Theta equals inverse tan 4 times 4 over 13. Plug that into your calculator. Lovely. So we've got 17.10 degrees, and that's the answer for this question over here. All right, moving on to the next one. Border it off. Okay, label the triangle. Got the adjacent, which is in between the two angles, as you can see. We've got the opposite, which is opposite that angle, and the hypotenuse, which is what we're left over with, the longest side. We've been given the adjacent and the hypotenuse. Which function has A and H in it? It's a cosine function, A over H, ka. Okay, so cosine theta equals 6 over 9. And if we want to find the angle, we have to use inverse cosine times 6 over 9, and then we can plug that into our calculator. And we get 48.18, but I'll round that up to 48.19. All right, degrees, don't forget that. All right, next question, let's label this triangle. So we've got the adjacent, which is in between the two angles. We've got the opposite, which is opposite the angle, and the hypotenuse. We've been given the adjacent and the opposite. Which one has O and A in it? It's a tan function. Yes, indeed. All right, so we've got the opposite over the adjacent. Substitute those values that we've been given in to that equation. You get 11.9 over 10. All right, so we've got 11.9 over 10. Enter that into your calculator. So 11.9 over 10. Oopsies, I did 11.9 over 1, which is going to give us the incorrect answer. So the correct answer is actually meant to be 49.96. So that's 49.96. My bad for that little error. Okay, moving on. Calculator errors can be so common, but let's label this triangle. Okay, be careful. So we've got the adjacent in between the two angles, the opposite the angle, and the hypotenuse, which is left over, and the longest side. We've been given the adjacent and the opposite. Which function has O and A? It's the tan function. O over A, TOA. So tan theta equals the opposite, which is 7.7, over the adjacent, which is 14. And rearrange to find the theta. So it's going to be inverse tan times, inverse tan times 7.7 over 14. Let's hope that I plug this into the calculator correctly. 7.7 over 14. Oh, there we go. That's much better. Over 14, and that's 28.81 degrees. That was a close one. Thought I was going to muck up again, but we made it. All right, next question, 6. Again, label this triangle. We've got the adjacent, which is in between the two angles, and that's that. We've got the opposite and the hypotenuse. We've been given the hypotenuse and adjacent. So which function has A and H in it? Yep, it's a cosine function. Ka, A over H. Substitute those values that we've been given in. So we should get cosine theta 4 over 5. Now we want to solve to get that angle. So we have inverse cosine times 4 over 5. And that will give us, let's plug that into our calculator. Plugging that into our calculator, we get 36.87 degrees. All right, we're almost there, speeding through. Now we've got number 7. Again, let's label the triangle. We've got the adjacent, which is in between the two angles. And then we've got the opposite, which is opposite that angle. And the I was going to say hydrogen, but it's hypotenuse. We've got A and H given to us, so that is the cosine function ka. And then we have to substitute those values in, which is 4.4 over 11. Plug that into, not so fast, we have to actually rearrange to find the theta. So that's inverse cosine times 4.4 over 11. Plug that into the calculator. And that is 66.42 degrees. All right, we've made it to the grand finale, the last triangle. So let's do it with a big bang. So first of all, adjacent in between the two angles. Then we've got the opposite the angle. And then we've got the hypotenuse, which is the longest side. We've been given the adjacent, opposite and adjacent. O and A, which function has O and A? It's the tan function, which is O over A. tan theta equals O over A, which is 3 over 3. Theta equals tan inverse tan times 3 over 3. 3 over 3 is basically 1, so what you should end up with is 45 degrees as your answer. Yep, which is shown on the calculator. All right, and that's it. Hope that was helpful. Enjoy, and that's all.